Hi guys, I'm back. Let's check out what I've been up to the past couple of months. Wow. So, while this might be the first time for you to see it, it's actually the second time I'm going to record this because, well, something didn't save. Um, so, here you can see the project I've been working on. So I've actually been working on programming some stuff because, well, programming is a lot easier to pick up in the evenings while being sort of exhausted from the work. And so programming was the way out for me to get into the hobby back again. And so I actually started making a Ferris wheel, like a mini Ferris wheel, 3D printed, and while it was going to have a motor on it and some lights, that will be simple, right? It's always with me in those like small projects that turn out to be huge. Anyway, in this image you can see the LED lights on the bench being lit by the ESP32, and also light patterns going through them, like a rainbow light pattern or so. I actually ordered separate NeoPixel LED lights and soldered them up manually. And in the back you can see the wheel. Here is a video of it all together. I'm actually using the laptop to control the LED lights, like changing the light patterns, because it connects to my program on the computer, which is a C++ program, which can send like a command and then it'll change the pattern. It's doing this via a Wi-Fi WebSocket, and so it's wirelessly controlled. And what you also saw right there, just at the end of the video, is that it can rotate freely. That's not because I'm using slip rings. I'm actually using a wireless power transfer there. Here you can see a video of it rotating. That's another ESP32 chip. And the program, the C++ program on the computer, can actually send commands to it, and so to make it rotate and position based on the encoder here at the top. Now here's another gimmick, like it's still on the bench, and I think it's at night here. You can see the LED light pattern. And so, while that was a lot of fun, and I'm probably far from finished with this project because I'm trying to make a fully configurable program, I kind of like went to some other project. So I started up drawing a Kromrey Generator. You can see the result here. This is drawn in Fusion 360. I decided to go this way because, well, the new generator is kind of a large project and it's way too hard to do right now. I don't think I can find the time to do that. Like, there's so much labor into it, and well, sawing, sanding, filing, taking time, winding, you know, iron and copper, and there's a lot of stuff to do. Well, the idea is that this could be done almost all by 3D printed parts, and it will be a much faster turnover, let's say. It's not like I'm going to sell it, but it's just like I can do this project in a shorter amount of time, while still working on the kind of like fancy generators. Oh wait, isn't it interesting to actually see the code of this Ferris wheel? Let's go ahead and do that. So what I was working on is this. This is the main of the... Wait, let me see. The light patterns chip. Basically, wait. It's opening a Wi-Fi socket, and the communicator program I created, which is called TCOM, it will communicate the variables which are in the light patterns class here. By the way, I'm not sure if you can follow, but it doesn't really matter. I'm just showing you this because it might be interesting to you. And if not, then just skip ahead to the, Kromrey part. So here's the class of light patterns, and there's a bunch of them. So like rainbow, cloudy, golden sun, forest, whatnot. And these are basically just controlling the lights. So this is a top class which controls a control module, which is the raw lights, basically just putting on the lights and putting off the lights, but without a pattern. This makes the pattern. And in order to communicate to this chip, I created this TCOM communication sort of like library, and all I have to do here is to, instead of making variables like booleans or int like numbers, I named them xbool for exchange, or xint for exchange int, and that way my C++ program on the computer can connect to them lights patterns ESP32 chip, or the other chip, for example, to turn on the motor and position to a specific position. It does the same thing. So I thought it was interesting to show you, and also at some point I'm going to put this stuff online. There's already a repository on my GitHub right now. It has the previous version of TCOM, and this newer version works, well, so much more advanced. Like, it's working with OPC UA and such. So I'll update it at some point. Now let's go focus on the workbench. So the idea started a bit random. I just kind of twisted and wound this coil, preparing it for making the Kromrey. And later I designed the 3D drawing you just saw, and well, obviously I printed it. So here's the result of a couple of parts. Here you can see the rotor, well, part of it already together, so you can have a feel of what that looks like. Basically it's comprised of multiple 3D printed parts, and then, well, put together in a logical order. And here is the parts separate. Basically the bobbin part. Also in between you can see some of the iron already cut here. Wait, here's the other part. So let's check it out. So the iron just goes in there, gets glued together, and well, as you can imagine, by itself the 3D printed part isn't that very strong, especially in this direction. If you kind of get a grip on it this way, it's much stronger, but altogether with the iron in place and the glue, it's going to be quite strong. As you can see, I left a hole there for a nut, so a bolt can go through and screw tight to the axis, so we can get a tight grip on the axis there. That's this hole right here. So that said, filling this up with iron is the first thing that needs to happen. The second one too, and that goes on top, like the way you can see it here. And basically then it gets clamped together by these well, outer bobbin parts. As you can see in the 3D drawing, I got a nice idea of how it should be shaped to make sure that it doesn't hit the starter poles. So I'm wrapping this coil around it. I didn't actually calculate or so how much of this coil is actually going to fill up this bobbin, but from previous experiences, always I choose to have 40 meters of wire, and these are 3 strands of 40 meters twisted together. So all in all, this is 40 meters of wire, so one bobbin, one of these is going to get 10 meters, and then the other gets 10 meters, and then there's one here and one there. I've been talking with ChatGPT about this stuff, because, you know, John Bedini in his Kromrey video tells us that he has a coil resistance of 0.4 ohms. This isn't gonna make it. This is like 2 ohms. So if I would want the 0.4 ohms resistance with a twisted trifilar wire of 40 meters, then we would need 1.46 millimeter gauge. This isn't gonna cut it because this is a 0.4 millimeter wire. So you say, why do you always wind these coils with the 40 meters? Well, that's from previous experiences, from my own motor generator kind of ideas. And at some point I also figured out that John Bedini was using the same kind of length. So I'm guessing that's like a magic length or so. This is his, well, my version of it, but basically I looked up the values, and this is his coil for the Bedini generator. So that's why the 40 meters, I think that's the rule. Tell me if I'm wrong, but that works for me. So this isn't going to be the Kromrey, but it's gonna be one, and it's gonna do the thing I want. So oh well, so here's some parts. Basically here are the starter poles, and these also get filled up with iron like this. So there's a bunch of iron there, and I cut iron enough for 3 of these already, so I was planning to do another one of these, and then it's time for gluing basically. So that's that part. Also on the image you saw some copper posts. These are here, and there's going to be this rod inserted. This has the screw thread, and I'm using these kind of bolts on it because they tighten, you know, unlike the normal ones. So I'm guessing either you remember the reason why we started this new generator previously, or well, I can tell you again. It's because of this little bug. It's like a variant of the Kromrey. I know it's different, but it does the same kind of trick. But the idea is here, we are making a closed flux path and opening it up, and basically a motor turns it and there are slip rings. Well, that's the same with the Kromrey, but it has 2 coils. And as you can see, it has the multiple strand wire, same. But the difference is here, well, this, the thing is with this one is that it slows down in this configuration. In this exact configuration, it doesn't actually work. So it does light a tiny light bulb, and while doing so it will slow down. But in a previous iteration I left the iron bars just about this much longer, and the coils were shifted a bit here and moved up, and it generated a tiny bit more even, so the tiny light bulb lit up a little bit more, and while doing so it didn't slow down. So I was hoping to, well, while cutting the iron bars and getting closer to the magnetic circuit, I was hoping to improve the results. Well, actually it actually failed. So it slows down and it generates less. So the key here to not have it slow down is to make sure it doesn't interact the coils directly with the magnet. So as you can see here, the proximity to the magnet is too close. So that's the reason why this coil, its magnetic field, has an effect on the magnets, and that's what slows it down. So the idea is to generate from the iron core, which gets magnetized by the magnetic flux gate, but not to actually generate with the coils directly from or close to the magnets. So as you can see on this generator, the coils do actually get close to the flux guides of the starter. However, in the back part here, we will have more of the coil, so focusing on generating from the iron and less of the coil on the other side, basically making it less focused on generating from close to the magnets. So even here you can see there's still quite a gap here, which is pure iron, and if that's going to be a problem, we could probably shift the iron magnets a bit back to make sure they don't interact directly with the coil. So I think there's a little bit of play there. As for the loads to attach to this Kromrey, we do have some LED bulbs like this one and that one, or there's one right here, and well, they will probably work. I think it's best to go with the old-fashioned, and this is like well, an incandescent light bulb here, and there's a couple of car bulbs here. And that's because these have a low resistance or low impedance, and the LED bulbs have a very high impedance. I mean, you know, that's what John Bedini has been talking about, matching the impedances, and it's kind of important. Alright, I'd almost forgot. There was this YouTube user asking if I was still alive, and I answered yeah. But I'm not going to work on that new generator now, because I don't think I'll find the time to actually finish that now. Well, I suggested maybe I should talk some about magnet conditioning, and well, while I read some more stuff about it, I actually decided this is well, also too big of a job. But let's draw up some stuff. So if this is your standard magnet, we kind of have the, you know, field lines like this. And basically, when looking at the Sweets VDA, we have a total different configuration in which the field lines are directed in a slanted manner. And the way to get this is to condition it. Kind of interesting stuff, but I sort of read more about it, and you need a capacitor bank of extreme high voltage along the lines of a couple of 1,000 volts and some microfarads to it. So it's also a kind of dangerous project. I decided not to go in too deep. So when you see John Bedini talk about it in his video, you see that he's saying that you need to, well, imply a sort of waveform on top of the magnet and drawing a couple of waves into it. But I don't think that's what's going on exactly. I think it's more like this. So just a single wave, and also with an offset. So in this case, this would mean if the zero line would be exactly in the middle here. Well, you know, in the middle there, then we would have a north here and a north here, and the south here and the south right there. But I think it's a tiny bit different. It's more like this, so by putting it into an offset and also implying this waveform on top of it, we get full north on the top, just a bit stronger on this side and a bit weaker on this side. Same with the south, it'd be less strong on this side and stronger on that side. The reason for doing that is to make sure that we can shift between a normal connected field lines between the two magnets and shift into connecting it to itself by biasing the offset field here. Wait, there was a waveform here, right? Making it dip into the 0 line here, making it also connect its own field lines to itself. So that means this generating coil right here sees nothing at one moment and then sees the full magnetic field lines at the other moment. Oh, well, theoretically this sounds freaking interesting, and would be awesome to actually succeed making this kind of magnet. It's kind of hard to do. Also, I think we were going strong on making this generator. Just making a bigger one now would be the more logical step. So attempting a version of the Kromrey would be the way to go. So if you're more interested into this Kromrey stuff, you can actually find this energy from the vacuum videos now on YouTube, because well, these guys died. The videos aren't sold anymore in the DVD series, cannot be bought. But some guy put it online on YouTube, so you can actually search and find it. If you're interested, I recommend you doing it. Also, I have something to say about that. This Kromrey generator, as shown by John Bedini, he's openly showing you this Kromrey in action, but he can barely light one light bulb with it, even though it's still speeding up. The design he's showing there isn't the actual final design that he meant would make this over Unity stuff. What you do see, however, in the town hall meeting, he is explaining his working version of the Kromrey generator, showing a bunch of light bulbs, and also it's showing that it can actually pull the motor, while if the generator is not generating, the motor cannot pull the generator in full, so it'll come to a stop. And if you look in that split second right there where the generator stops, you can actually kind of make out that these generator coils are slightly bigger. So it's kind of also a response to the limited energy potential YouTube channel. I hope you find a couple answers here and there, and for all of y'all, thanks for watching and hope to see you next time. Bye bye.